My name's Rob, or RobNet if you want to abbreviate into my name and what I do, and also my Twitter handle. I was making these T-shirts just before I left, and my daughter, who's 7, said, "Why are you printing those awful T-shirts?" I was like, "What's awful about them? What? Awful? No, AwayFL. Never mind. Anyway, so the AwayFL is the name for the thing that I work on, and awayfl.org is the URL that you can find it. So we're here to talk about bugs. If you're a developer, then you'll know this never happens first time. That's okay. I mean, it's not necessarily expected, but if we are going to be doomed to fix bugs, then we might as well enjoy doing it, right? It's not necessary to be so dour about them. They are sometimes things which are hiding potential benefits that you can integrate into your game. If you aren't actually aware of the solution and why the bug exists in the first place, it can come back to bite you later. So patching is good, and I understand people need to ship games, and a fixed game is better than no game at all. But if you do have the extra time, solving a bug and actually finding its root cause can be more beneficial in the long run, and I feel also a little bit more satisfying. So that's kind of the angle I'm going with today. So as I mentioned, my day job is working on the AwayFL emulator, which is a Flash emulator. That's Adobe Flash, if for anyone who is old enough to remember such a thing. What's that? Macromedia Flash, I'm sorry, yes, exactly. Adobe just stole it. I've been working on this for years now. I mean, if we're kind of counting where it started in terms of actual code, probably around 10 years. But it's only been a sort of official open source engine for a little less than that. And yeah, I'm not going to be speaking a huge amount about this today. But if there are any devs in the audience who are interested in old Flash content and have some that they might want to be able to run again in a web browser, then AwayFL is hopefully ideal for your needs. It's open source. It has a very permissive license that has no commercial restrictions. And we have a community that is actually, as it happens, a useful thing to have when you're trying to fix bugs. Communities are great for free QA and feedback, but they're also a place where people can come to ask their own questions about the engine problems they're having. So if you're at all interested, you can find us at awayfl.org. And you've got a lot of stuff on there, not just the engine, but you've got the links to our Discord. You've got a test thing you can actually run your own Swift in to try it out. And if you have problems, just ping me on Discord, ask me a question. I'm always friendly and happy to answer. So here's just a quick example of one of the things. Now, I had this problem before, but refreshing made it go away. Excellent. This is one of the latest ones that we've released with Cool Math Games. And while we're waiting for the sound, there we go. This is this is probably a classic you may or may not remember if you played Flash games a few years back, called Wonderput by Dampnat. This is running in AwayFL, and it's quite a complex game. It has a lot of visual complexities, but it's also got complex ball physics and everything else. So this is fairly high level, and a result of years of actually gradually improving the engine and adding more features and everything else. But it was only released on Cool Math like a couple of weeks ago. So if you remember this and fancy playing it again, check it out. But yeah, bugs are what we're here to talk about. So I guess bugs is what we're going to get. I do feel like the amount of problems that exist with bugs are generally as a result of various different things that are not necessarily your fault, but just slip-ups that occur, and how to fix them is all part of the sort of challenge. So here's my breakdown of various bug types, if you like. You have syntax bugs, which are your usual kind of runtime error bugs, where you just get a stack trace. Usually it's something to do with a null value. These are usually not too difficult because you've got a trace of exactly where the bug occurred. You can trace back up the stack and see where things went wrong and why the value is null. So they're probably the easiest type. Then the next one down, implementation, is what I'm referring to, where I say something which is running, but not in the way that you intend it. So this might be because you have like an iterator that's going one index too far, or something which is not necessarily easy to spot initially, but is causing the behavior to be incorrect for whatever reason. So this could be a visual behavior, this could be something else to do with sound, whatever. Data flow is just a little bit more complex again, and generally about systems working together. So in a game, you obviously have you often have several parallel systems, like you have graphics, you have physics, you have user input. These all have to come together, and occasionally things happen in an unexpected order, and that can cause a data flow bug. Deployment, which is probably one of my least favorite, which is what I refer to when talking about platform bugs. So the most guilty party of this obviously being iOS, which, I mean, you know, they're a $3 billion company. You'd think they'd be able to build something that didn't actually create these problems. But if you're multi-platform deployment and you have, a problem with one platform but not on any others, that's generally what I call a deployment bug. And yeah, they're someone else's problem, essentially. Someone should have fixed it in the platform but didn't, and now it's your problem. So that's kind of why they're annoying. And I put memory bugs in there just because memory is one of the most difficult to deal with, it's kind of we're not going to touch on that, but it is something which has a whole other set of things, probably for another complete talk to talk about. I also added a couple of extra ones here for fun. So Mandel bug is a bug that appears random, and you don't know what's actually causing it, and it doesn't happen in any kind of consistent manner. And a Heisen bug is the kind of another random bug, but one that when you actually test for it, it suddenly stops creating a bug and fixes itself. And then when you stop testing it, it goes back to. So these are the sort of, this is the breakdown that I've come up with anyway. And we'll have a look at a few of these. So yeah, first of all, a syntax stack trace. This is the sort of thing that you would get in a web browser. Because AwayFL is built on TypeScript and WebGL, this is kind of what I'm dealing with. But a stack trace is pretty common in any language, so I'm sure this is familiar to many people. And you see something is null. You can set back up back up the stack. You can see where this is being called, something to do with B2 World Create Joint, which is actually something to do with the Box2D library, which is a 2D physics engine, and you can go back up and see where this is called. Not too difficult, but quite a common thing. And I haven't mentioned testing yet, so I suppose I better get this out of the way. Testing is fine. Unit testing is fine. I don't think it solves all problems. My sort of only beef with it really is that when you're dealing with bugs, you're actually dealing with something that needs to be fixed. When you're creating tests, you're kind of guessing what might need to be fixed later, but don't actually know. So the time spent creating tests could be time spent actually fixing bugs. And I think there's definitely a balance. You want to have some tests. You want to try and automate a little. But you shouldn't put all your eggs into that basket necessarily. So, enough talk. Let's fix a bug. Okay, this is one of the earlier games that we released, actually, Escaping the Prisons by. So this is part of the Henry Stickman series by Puffballs and United. Yeah, let's see what's wrong with this.
Oh, you. You're free to go. Not really, but you've got a package. Don't get your hopes up. We've already checked it for anything useful. Haven't we, Dave? What? Yeah, of course I checked it. I mean, if I didn't check it, I'd lose my job. I don't want to lose my job. See you around. Free to go. Thought that was
So I tend to choose the rocket launcher, so let's just do that. But this shouldn't be happening. So seems to have paused. Okay. Oh, no, it's going. Paused again. Yes. So clearly something's up there. The animation sort of stutters, it stops, it starts, it stops, without any kind of interaction. We get to the end at least, but it wasn't perfect. So let's see what's actually going on here. We've got the advanced frame method in movie clips. So when we're dealing with, first of all, let me just show you what I'm talking about. So when creating old Flash games, you tended to deal with this. This is the editor, now called Animate, but it used to be called Flash Pro. And you have a bunch of timeline elements. So timelines are basically individual frames of animation, and you can sort of scrub through them. You can jump to different points, but more often you're just sort of playing them back, and the animation plays on the screen. And you can have movie clips inside movie clips. So this is one movie clip, this whole thing, but then inside any one of these frames, you could have other movie clips and so on. They all have their own timelines. They can all animate as well. So it's a kind of hierarchical structure of movie clips. The thing that actually advances the frame, at least in our emulator, is in the movie clip class and is advanced frame. So this is where I've sort of jumped ahead a little. This is where I know the bug is. Let's just take it from here and see if we can work something out. So you can see here that advanced frame internal is where the actual action is. And if there's no frames to be skipped, you just advance the frame. Flash works on something called rubber banding when it comes to frame rates. So when you have a lot of action going on a single frame, it'll actually pause the frame until the action is completed, executed all the code, and then it'll try and catch up again with the frame rate that it was trying to hit. So if you set it at 30 frames a second, and you just have one frame that has a lot of stuff being created maybe, or a lot of code being executed, it'll sort of slow down for that because it needs to complete the execution, and then it'll try and sort of catch up again. And it also does this when you have certain types of sound playing that are supposed to be synced to the animation. So if a sound is supposed to be synced for maybe a speech sync or something, then you need to be able to accurately predict when the frame's going to land and so on. So this is what this is doing. We've got this sync sounds thing here. It returns a number of frames that you might need to skip to catch up with the sound that's playing so that you maintain sync with the sound. And then if you do need to update, then you just keep going by adding your frames until you have no more frames to skip and you're back up to the point where the sound is. However, this is actually coming back with a negative value, which means that the player thinks that the playhead is actually behind the sound. Sorry, is in front of the sound, so it needs to wait for the sound to catch up, which isn't correct. So if we can drill into this, we can find out what is actually going on here. Excuse me. So we have sync sounds, and then we have this one, which doesn't actually, this is not linked correctly, so I have to say, well, what the hell is sync sounds? Oh, okay, there's something in movie clip sound, which is executing sync sounds. Fine, we'll just sort of jump into this, and we end up in this frame here. So this is returning the number of frames that it thinks it needs to be skipped. And there's some stuff at the start, like, if the sound is stopped, then it doesn't need to skip anything. If the sound is complete, it doesn't need to skip anything. That's all fairly. But the meat of it is down here, and the git diff might actually give away what the fix actually is, because I've obviously had to regress this to show you what the problem was so that I can then fix it. But the problem here is with the element time. Now, okay, it's probably a bit too much to ask you to work out what the problem is. But with a little help from the git diff, we can see that this element time is being caught before the playhead is playing here. So it's grabbing the time of the current sound, and then if the sound isn't playing, it actually plays it from a different time. So this is an ordering bug. It's a little bit of an implementation bug. It's an edge case, because this only really happens when a sound isn't playing and needs to start. So it doesn't happen all the time, which is why at the start of the game, things played fine. But it's a good example of just your bog standard implementation bug. This is being grabbed in the wrong order, so the element time here, which is then being used to calculate the offset, is being set in the wrong place. So what we need to do is put it into here, save, back to the game. Let's see if that fixed it.
Oi, you.
Well, okay, live coding's great, right? But you get the idea. Oh, man. Yeah, should have updated. Maybe it's yeah, it's probably a caching issue. But either way, you can see where I'm going with this. So that's an example of an implementation bug. It was presented in a weird way that didn't look like it was anything to do with sound. But as we sort of drilled down, you could find out exactly what the problem was and fix it. Now, you could have just seen the play advanced frame thing and gone, oh, it's negative. I'll just set a clamp on that, and it won't ever be negative, and then problem solved, right? But it doesn't necessarily help if you have a similar problem down the line, which has a slightly different implementation problem, and it's still related to the same buggy code. So actually going in, finding out the root cause of the problem and fixing it saves you time in the long run. And this was pretty easy. You could jump in and actually fix things relatively quickly by sort of skipping ahead in the game. But what happens if your bug only happens like 10 minutes in? Well, this is where you need to create tests of your own that just replicate the bug. And yeah, essentially it's reducing your test loop so that every time you test, you're not just wasting time getting to the point where the bug is. It's pretty self-explanatory, really, but the number of times to see this not happening with people just constantly clicking through things is insane. So, don't waste your time with a massive test loop. You should be trying to isolate the bug first. Sometimes isolating the bug actually finds the cause anyway. And the sort of things I'm talking about, we've got a few examples here from AwayFL. So, you've got like an animation test, you've got a filter test for like 2 bitmaps filtered on top of each other. A masking test, that flicker is actually correct. Thank you very much. This is just taken out of context. When it's in the game, it's fine, but the mask is still fine to test. And then the one on the bottom right is an actual memory test where you're kind of disposing and creating a bug, a bitmap, and so you can just click away and then see if memory's clearing or not. But this is the sort of thing that really speeds up your test process. So here's an example of something which requires this. It's another Flash classic, balloons. And we have, we can set down a few of these guys. We can start around. You're probably playing this at work, right? Oh shit, that's quite loud. I better not. Maybe I'll just mute it so my boss doesn't hear. Hang on a sec. What? The mute button stopped working. Okay, so that's a problem. Obviously, we don't want people to get into trouble. It mutes whenever it's playing, but then it doesn't mute on another round. So that's kind of weird. Okay, let's see what we can work out here. But first of all, let's actually create a test that reduces our test loop, because you could see that this takes quite a long time to get into. Once isolated, this is the test. You create a balloon, you pop it, fine. Create a balloon, you mute, you pop it, muted, you create a balloon, pop, not muted. So this already kind of like gives you a little bit more context of what the problem is. It's not a problem with things that are on screen, but it is a problem with new things. So we can go back into code and actually have a look at what might be causing this one. Again, it's something in the movie clip class. And we are using something called set sound volume. Oh, well, I suppose I could actually do it in here. So obviously, everyone who is fixing bugs has and is familiar with the debugger of their particular language. And in JavaScript, it's the DevTools thing. So here we are in DevTools. And let's just have a look at what's going on. So we know from looking at the code that the sound button is using something called set volume on a movie clip to set it to 0 and then unset it again. And so we can create a balloon, we can pop it. Let's see, when we press this, we get a breakpoint. So what I've done here is set up a breakpoint, which is, again, a fairly common thing in coding. And this is kind of where these sorts of things come in useful, because not only can you use it to sort of adjust values on the fly, but you can also use it to see where your data flow is going and how things are executing through the code, stepping through it to just sort of work out exactly where the problem lies. And so far, so good. We are actually setting the volume. And then you can see that it goes into this loop, and it's setting the volume of all the children inside the movie clip. So the movie clip, because it's contained other things potentially that also has sound playing on it, it mutes those as well as it goes down. And you're like, okay, fine. That's good. What happens if you add something new? Well, there's nothing for that to adjust the volume. If you have something that's already muted and then you have a child added underneath it, that should also be muted. And that's not currently being catered for here. So what we need to do is add that into the code, and we should be good. So we can use something called set parent, excuse me. And this needs to, first of all, call the super. And then we want to just make sure that this child thing that's being added has the same volume. So we can do if parent in if parent is so checking that the parent is in fact a movie clip, then you set this particular movie clips. So this sound volume equals parent sound volume. Oh, and in order to, this needs to be failed container so that it matches the super. And I can save this now. If I rerun this, and try this out, fine. It works, hooray. So we fixed the bug, right? That's a fix. Except it isn't the right fix, and this is the problem that I stumbled across last night. So in writing the last bit of this presentation, I was trying to find in my Git history where the bug was fixed. And I was looking for this particular line, this set parent stuff. And I was like, it's not here. Where is it? I definitely have it in the live version, but I don't have it in the Git history. And after an hour and a half of searching, I suddenly realized what the problem was. And the problem is, and this is something that is a kind of lesson, I suppose, in bug fixing, all of this hierarchical stuff is nonsense. Flash doesn't actually do that. So this was a fix that was a fake fix and would have caused other problems if I'd actually kept it in there. All of this should have actually been removed. And the real problem was in the way the sound was being set in the first place. And that was to do with where is it? The sound manager. So inside the sound manager, you have a set volume which sets the volume on the movie clip. And this is AVM1 because this game was an AS2 game. So the there's a mode in the sound manager where if you don't provide a target for the sound, then it just mutes a global sound. And this was fine if you didn't provide a target. However, there's another additional constraint with this, which is that if you provided a target that was the root movie clip of the game, that acted as though you hadn't provided a target. So this was the actual real fix, and I won't bother typing this because my fingers are getting a bit ropey. But you can see here that if you add an additional step saying, is this an AVM scene, so is this like a root movie clip, this will fix. This will also behave like a global volume. And this was the fix that I actually needed. But it wasn't the fix that fixed it initially. So sometimes not digging deep enough gets you into trouble later because you realize that the fix that you actually had was the wrong fix and it's still causing problems further down the line. And you get to miss the majority of DevGAMM parties as a result. So hopefully that's some sort of lesson that everyone can take away from this. Anyway, I suppose the sort of the summary of this particular situation is best summed up in a quote from Hitchhiker's Guide, where the robot is calculating the meaning of life, and the meaning of life turns out to be 42. And that's like, well, what does that mean? It's like, well, once you know what the question actually is, you'll know what the answer means. And in bug fixing, it's kind of like that, where you've got a result which you didn't want, but you need to find out what the actual cause of the problem was in the first place. And once you understand the cause, then you understand the bug. So it's, I don't know, words to live by, maybe. So some final thoughts we have. So when trying to fix bugs, use strong types initially. That's always a good idea. We use TypeScript because everything's running in a web browser. So JavaScript is obviously also an option, but TypeScript gives you that additional security and saves you from syntax bugs. Have some automated tests. I mean, I'm not saying don't have any, but I don't think they're a panacea, and it's good to balance that with actual bug fixing time. If you've got something that's a long way into the game, reduce your test loop so that you can actually iterate quickly. And ask some better questions if you're actually trying to find the root cause of the bug, rather than just assuming the first fix is the correct one. So sometimes you need to dig a little deeper to find out what's actually going on. Oh, and another one's very important. Don't get too stressed about this. It's only bug fixing. I probably should have just left it and gone to the party, right? But I'm a stubborn person, so whatever. Oh, and also, in a few years, we'll be able to just let the robots do this anyway, so this will all be obsolete. But in the meantime, hopefully you have some fun fixing bugs and remembering that solving is a little bit more satisfying than actually just patching. So thank you very much for your time, and enjoy the rest of the conference.
Thank you. So I guess we have some time for one or two questions. Okay.
Thank you for the presentation. I'm happy that I'm here. I was grew up with Macromedia Flash, and I became HTML5 game developer. So everything that you show was like very sentimental for me. I have a question about testing, but with the integration testing. Do you have any experience how to make integration tests?
Yeah, so integration testing, continuous integration testing is useful for larger projects, definitely. And I've used Jenkins in the past with Maven and stuff for Java setup, but I mean, you can use any of the sort of standard test tools. And integration testing definitely has its place, especially for online testing, where you have a lot of server testing as well as client testing. But I think that for smaller stuff, it all depends on what you're actually trying to produce. If you're writing something that you're going to be using for a number of years, by all means, set up continuous integration, get it all going. If you're doing something for like maybe, I don't know, a contract for an ad agency that's going to be only like 6 months and then they'll move on to the next thing, it's a little bit overkill. So yeah, I think there's definitely a balance, but continuous integration for large projects is definitely a recommendation, sure.
Thank you. I guess we have some time for one more question. So do Okay, cool. So
I am around if you want to ask about AwayFL. So just grab me in the conference floor. I'll be here for the rest of the day. Yes, go on.
Yeah, just a bit fast question. Do you have bugs that are browser dependent, so that are not really related to Flash, but to the browser? And another question: how do you make the test cases from these games? Do you code them from scratch, or do you reuse the original code of the games that is being in question, and you just strip it down to the bug?
Right. So yeah, so the first question, are there still bugs that are caused by different browsers? Yes, there are. And Apple is by far the worst offender. I don't know what it is about Safari and why they think it's so great, but it really is the most frustrating thing. Everyone else seems to have worked this out, apart from Apple. The most recent one I remember is that they have something to do with activating sound as a security measure when you touch on the screen. And one of the differences, the only people that do this is where you have an iframe inside another window, and most people allow you to activate it outside the iframe, and then the iframe is automatically activated. But Apple go, oh, no, that's not secure enough. We need to also activate inside the iframe. So then you have to have another little bit of code to patch that and smooth all that abstraction out. It is frustrating, and it still happens, but I mean, I've been in this industry for over 20 years, and it's nowhere near as bad as it was at the start. So in some senses, I'm very grateful for that, but those sorts of problems still exist, sadly. What was your second question?
How do you make out test cases from games?
Oh, yeah. So in general, you take the code directly from the game and then try and isolate, because a lot of the time, reproducing things is hard to do just from scratch, and you're trying to just whittle it down to the bare minimum. So sometimes isolating and just recreating doesn't create the bug. So you need to actually grab the code from the game itself. And what we do is then create little test Swift files. So they're still Flash, and they're still running as they would in anything else. But they're as small as you can get them and as immediate as you can get them. We do actually have a visual test tool that we wrote, which is actually slightly deprecated now, because we used to be able to run the Flash player alongside the AwayFL player and then visually difference both of them to see if everything was correct, and that was a level of automation. But ever since Flash stopped being activated in browsers, it's kind of hard to do. So you can still set up visual tests for these sorts of things if you have like a ground truth image and you just test against that, and that's still an automated process. But it is harder to do now that Flash is no longer accessible in browsers, for sure. Yeah, I mean, I still have Flash installed on lots of different things. Mac is actually not so grumpy. Windows is constantly telling me to uninstall it. It's like, danger, your computer will explode. Stop using this software. But it's not so bad on the Mac. So yeah, I recommend if you're still trying to run Flash, then Macs are a little bit of an easier time.
Okay, thank you.
Thank you.
Yeah.